Hey guys, this looks like a fun one. We're given that the pink and the blue rectangles have the same area, and it wants to know what is that area. This is day 26 of the 2025 Advent calendar. And if you want to try this one on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, looking at this triangle, let's complete this rectangle, and this triangle will be congruent to this triangle. It'll also have an area of 12, and we can match the font. And same thing up here, let's complete this rectangle, and this triangle is going to be congruent to this triangle. It will also have an area of 3. Now let's focus on this little rectangle right here. Let's give it a base of x, and let's find an expression for the height. To do that, we're going to use the formula for the area of a rectangle. Its area equals base times height. For this rectangle, the area is equal to 6, the base is equal to x, and the height is equal to the question mark. From here, we can divide both sides of the equation by x, and we end up with the question mark is equal to 6 over x. So we can change this question mark into 6 over x. And now from here, let's find the length of this side of this triangle. To do that, let's focus on these two triangles. Each of these triangles contains a right angle. That's this one here and this one here. And these two orange angles will be congruent because these are vertical angles. And then since these two angles match, the third angles will also match. So we know the two triangles are similar. Let's rearrange them like this, and let's look at these notes for similar figures. If the scale factor is equal to a over b, the area ratio is going to be a squared over b squared. This will be true for all similar figures. So for these two triangles, since we know their areas, let's focus on the area ratio. In the place of the a squared, we can plug in 12, and in the place of the b squared, we can plug in 3. 12 divided by 3 can simplify to 4 over 1. And then since we have a squared over b squared, let's see if we can write these as squareds. 4 is the same thing as 2 squared, and 1 is the same thing as 1 squared. So now we have a squared over b squared is equal to 2 squared over 1 squared. And now we have a pretty good idea what a over b is going to be equal to. It'll be 2 over 1. So the ratio of the big triangle to the little triangle is 2 over 1. So if this side is equal to x, this side is going to be twice as big as this, or in other words, 2x. So now we know this question mark is equal to 2x. And we can also do the same thing for this side here. So if this side of the little triangle is 6 over x, this side will be double that, or 12 over x. So we can change this into 12 over x. And now we can write an expression for the base of our blue rectangle. It's going to be 2x plus x, or 3x. And there's a couple other things we can fill out. This, I don't know if we're going to need it, but it is 6 over x. And if we extend this over here, this will be 12 over x. And I don't think we know anything else. Now let's focus on this triangle and this triangle. This angle will be right, and this angle is going to be right. And then this orange angle will equal this orange angle. And we know that because of corresponding angles. Anytime you have a transversal cutting through two parallel lines, these two angles are going to be congruent. And then the third angles will also be congruent, which means these two triangles are similar. So that means there's going to be some scale factor k between this triangle and this triangle. Let's call the base k times x, and let's call the height k times 6 over x. Let's rearrange this to 6k over x, and let's clean these up a little bit. And then this will also be 6k over x. And now we have all of these and all of these. Let's copy it down here and focus on our two rectangles. We were given that the pink area is equal to the blue area. So let's see if we can do anything with that. Each of these are going to be base times height. The base of the pink area is kx plus 3x, and the height is 6k over x plus 12 over x. And then for the blue area, the base is 3x, and the height is 6k over x plus 18 over x. And now let's see if we can do anything with this. For the base of the pink rectangle, each of these terms contains an x. So let's factor out the x. And after we factor out the x, on the inside we'll be left with k plus 3. And then for the height of the pink rectangle, each of these terms contains a 6 over x. So let's factor out 6 over x. And after we factor out a 6 over x, on the inside we'll be left with k plus 2. And then on the right-hand side for the base of the blue rectangle, let's copy down the 3x. And for the height, we can factor out another 6 over x. And after we factor out the 6 over x, on the inside we'll be left with k plus 3. And then back to the left-hand side, this x and this x in the denominator can cancel each other out, and the 6 is still there. And then the same thing on the right-hand side. This x and this x are going to cancel each other out, and the 6 will still be there. And now each side of the equation contains a 6 and a k plus 3. So let's divide both sides by 6 times k plus 3. On the left-hand side, all of this is going to cancel out, and on the right-hand side, all of this is going to cancel out. So we're going to be left with k plus 2 is equal to 3. And after we subtract 2 from both sides, we get k is equal to 1. And now we can update the k's in our diagram. This k is equal to 1, so this whole thing is x. And then this whole k is 1, which means this is 6 over x. And same thing for this one, it is 6 over x. And now we're ready to find the areas of our pink and blue rectangles. For this right here, the 12 over x and the 6 over x, they can add together to give us 18 over x. For the pink area, the base is 4x and the height is 18 over x. And for the blue area, the base is 3x, and the height is these two added together, which is 24 over x. For the pink area, this x and this x on bottom are going to cancel each other out, and 4 times 18 is equal to 72. Let's give it a label of square units and check out the blue area. This x and this x are going to cancel each other out, and 3 times 24 is also equal to 72. Let's give it a label of square units and put boxes around each of these. Either of these is the answer to our question. The pink rectangle and the blue rectangle both have an area of 72 square units. How exciting. I want to share something really quick. There were 2 routes that I went down that gave me a dead end. I thought it'd be fun to show them to you though. If we go back to this point here, I ended up looking at this rectangle and I noticed that I could split it up like this and find out that each of these are equal to 6, or the whole thing is equal to 12. I also looked at this rectangle and identified that it is also equal to 12. From here, I was totally stuck. I didn't know any way that these could help me. So I ended up cutting these 2 rectangles out of the video. I did find the kx, which I ended up using in the final version. But first I looked at this blue triangle and found the sides of that, and looked at this red triangle, found the sides of that. And then I showed that the 2 triangles were similar, used this ratio to do all of this math, and I ended up with 18 is equal to 18. All this work did me absolutely no good. So then I had to backtrack all the way to here where I recognized that the pink area was equal to the blue area. And this is a really good example of why I like Brilliant so much. You're not going to lose any time doing something unproductive. Everything you do in Brilliant has a purpose. You don't have to backtrack. All the courses are designed by experts. They have world-class teachers from MIT, Harvard, and Stanford. It's easy to tell they put a lot of thought into the explanations and the interactive examples. I'm currently in the middle of this course on truth and lies. It's all about logic or deductive reasoning. You get to think about the details that would exclude certain values and include others. It's really a lot of fun. Lately, I've been teaching some of my younger students about percents, and I let one of them go through this course on Brilliant, and they got through it and they really liked it. The clever interactive examples and the little rewards along the way worked great. It never occurred to me until now that Brilliant could work so well for younger learners too. The courses do overlap with stuff they're also learning in school, and if they stick with it, they can end up building a really good foundation for algebra, geometry, and even calculus, and have fun doing it. I'm going to start implementing Brilliant with some of my younger students. I'm excited to see how it goes. And if you want to try Brilliant for free for 30 days, visit brilliant.org/andymath or scan the QR code on the screen. Or you can click on the link in the description. If you go through this link, Brilliant is offering 20% off an annual premium plan, which will give you unlimited daily access to everything Brilliant has to offer. How exciting.